In today's video, we are going to solve the problems related to linear differential equations. So what exactly are linear differential equations? Let us see first. So there are the two way we can represent the linear differential equation. One form is dy by dx plus py equals to q r over r. The another form dx by dy plus px equals to q. So these are the two forms at the basic level of the linear differential equations. And here p and q are constants. Here also p and q are constants. And here p and q are function of x. Function of x. That is either are p and q are constants or p and q are the function of x. Here also p and q are constant or p q are function of y. And here we do find integrating factor. The integrating factor is given by e raised to p dx, and here integrating factor is given by e raised to integration of p dy. Now solution in first case is given by, that is general solution. There are the two types of solution. One is the general solution, another is a particular solution. So here I am talking about the general solution. So general solution for the case 1 is given by y multiplied by integrating factor equals to integration of q into integrating factor with respect to x plus c. So this is the general solution of case number 1. And the general solution for case number 2, in place of x y will come, and in place of y x will come. So here for the case number 2, general solution is given by x into integrating factor equals to integration of q into integrating factor, and integration is with respect to y plus c. So these are the two very basic forms of linear differential equations. Now I am going to solve some problem based upon this type of differential equations. Example 1, find general solution of differential equation dy by dx plus 1 upon x y equals to x square minus 3x. Solution. Now first of all we write the given equation as it is, dy by dx plus 1 upon xy equals to x square minus 3x. Now we'll write the standard equation, dy by dx plus py equals to q. It is equation 1 and it is equation 2, comparing respective terms of 1 and 2. So when you comparing, p equals to 1 upon x and q equals to x square minus 3x. After deciding p and q, we have to find integrating factor. So integrating factor is given by e raised to integration of p dx. So that is e raised to, what is p? P is the 1 upon x with respect to x. So e raised to integration of 1 upon x with respect to x equals to e raised to log x. And we know that e raised to log x equals to x. So we got integrating factor equals to x. This is the step number 1 is over. Now general solution. General solution. So what is the general solution? General solution is nothing but given by y into integrating factor equals to integration of q into integrating factor with respect to x plus c. So this is the general solution. So y into, what is the integrating factor? X equals to integration of q. What is the q? X square minus 3x multiplied by integrating factor, that is x with respect to x plus c. Now so xy equals to here x cube minus 3x square with respect to x plus c. So xy equals to integration of x cube is nothing but x raised to 4 upon 4, and integration of x square is nothing but x cube upon 3 plus c. Now x is common, so we get x cube upon 4 minus here 3 get cancelled, x square plus c, x and x get cancelled both sides. So after that y equals to x cube minus 4 x square upon 4 plus c. So that is y 4y equals to x cube minus 4x square plus 4c. Let 4c equals to another constant c1. Therefore 4y equals to x cube minus 4x square plus c1 is required solution. Example 2. Find the general solution of dy by dx plus y equals to e raised to x. Solution. First of all, what we do? We write as it is dy by dx plus y equals to e raised to x. Call it 1. Comparing it with standard equation dy by dx plus py equals to q. Now comparing them, after comparing we get p equals to 1 and q equals to e raised to x. Now we need to find integrating factor. Integrating factor nothing but e raised to integration of p dx. So that is e raised to, what is a p? P is a 1 dx, that is e raised to x. So integrating factor equals to e raised to x. After that, the general solution. General solution is given by y into integrating factor equals to integration of q multiplied by integrating factor, and the integration is done with respect to x plus c or c dash. Now y into integrating factor, that is e raised to x, equals to q nothing but e raised to x, and in this question integrating factor is also x with respect to x plus c dash. So y into e raised to x equals to e raised to 2x plus c dash. The integration of e raised to 2x is nothing but e raised to 2x upon 2 plus c dash. Now we require to do a little simplification. Now this can be written as y e raised to x equals to e raised to 2x plus 2c dash upon 2. Cross multiplication, 2y e raised to x equals to e raised to 2x plus 2c dash. Let 2c dash equal to c. Therefore 2y e raised to x e raised to 2x plus c. This is required general solution. Example 3. Find the general solution of x into dy by dx plus 2y equals to x square log x. What do you observe here? Here dy by dx is multiplied to some function. Whenever you are dealing with the linear differential equation, it is important that dy by dx should not get multiplied to any variable. Like here x is the variable that is multiplied to dy by dx. So first free dy by dx from x. So that can be done by dividing both sides by x. So step 1, to solve this differential equation, dividing both sides by x, so that dy by dx not multiplied to any variable upon x equals to x square log x upon x. So we get here dy by dx x upon x plus 2y upon x into x log x upon x. This x get cancelled, this x also get cancelled. We get dy by dx plus 2 upon x y equals to x log x. Now comparing this equation, let us call it 1. and comparing it with dy by dx plus py equals to q. So we have p equals to 2 upon x and q equals to x log x. The next step, that is step 2, we need to find integrating factor. So integrating factor equals to e raised to integration of p dx. So that is e raised to 2 upon x with respect to x, that is e raised to integration of 2 upon x, 2 as it is, integration of 1 upon x is log x. So that is equals to e raised to log x square, that is equals to x square. Therefore, integrating factor equals to x square. This step is over. Now step 3. Step 3, applying general solution formula. General solution is given by y into integrating factor equals to integration of q multiply to integrating factor with respect to x plus c. So integrating factor is x square. So x square q nothing but x log x, and integrating factor is x square, that is integration of x log x square dx plus c. Now x square y equals to integration of x cube log x with respect to x plus c. As per as LIATE rule, log x equals to u and x cube equals to v. And we now apply product rule of integration. This is what the product rule, the product rule of u and v, that is a u integration of v dx minus integration of box and du by dx integration of v dx, again the dx. If your product rule is not perfect, product rule of integration is not perfect, then I request you that go to my channel and visit the playlist of integration and solve all problems of integration related to product rule, so that you can do very well these differential equations. Now next step, here is x square y keep as it is. Now fit into the formula product rule, that is a u nothing but log x, v nothing but x cube with respect to x minus integration of box, and what is that, u derivative of u, that is log x with respect to x, and integration of v, that is x cube with respect to x plus c. So x square y equals to log x and integration of x cube nothing but x raised to 4 upon 4 minus integration derivative of log x is 1 upon x and integration of x cube is x raised to 4 upon 4 with respect to x, here is with respect to x plus c. Here in place of c we can write c dash. Now next step, x square y equals to x raised to 4 log x upon 4 minus 1 upon 4 outside integration of x cube with respect to x plus c dash. So x square y equals to x raised to 4 log x upon 4 minus 1 upon 4 integration of x cube is nothing but x raised to 4 upon 4 plus c dash. Now simplification, x square y equals to 4 x raised to 4 log x minus x raised to 4 upon 16 plus c dash. Now a little simplification is required, that 16 will go that side. So 16 x square y equals to 4 x raised to 4 log x minus x raised to 4 plus 16c dash. Let 16c dash equals to c. Therefore, 16x square y equals to 4x raised to 4 log x minus x raised to 4 plus c. This is required general solution. Example number 4 here. Find the general solution of dy by dx minus 3 upon xy equals to 4x. Step 1. Writing it properly. Dy by dx plus minus 3 upon x y equals to 4x. Comparing it with dy by dx plus py equals to q implies p equals to minus 3 upon x and q equals to 4x. Step 2, we need to find integrating factor, that is integrating factor equals to e raised to integration of p dx, that is e raised to integration of minus 3 upon x with respect to x, that is equals to e raised to minus 3 taken outside 1 upon x dx, that is equals to e raised to minus 3 log x. This can be written as e raised to log x raised to minus 3 equals to x raised to minus 3 equals to 1 upon x cube. So this is integrating factor. After this, we require to find out the general solution. So general solution is given by, what is the formula? Y into integrating factor equals to integration of q multiplied by integrating factor with respect to x plus, let us say, c dash. So c dash or c. So we don't know whether to write c dash or c. So write down c, okay. If we want, later on we will change it. Y into integrating factor, that is 1 upon x cube equals to q nothing but 4x upon x cube with respect to x plus c. So y upon x cube equals to 4 is taken outside, 1 upon x square with respect to x plus c. So y x cube equals to 4, and integration 1 upon x square can be written x raised to minus 2 with respect to x plus c. Now further simplifying, we get y upon x cube equals to 4. Integration of x raised to minus 2 nothing but minus 2 plus 1 upon minus 2 plus 1 plus c. So y x cube equals to 4 into x raised to minus 1 upon minus 1 plus c. So that is y x cube equals to minus 4 upon x plus c. Now that x cube taken to the right side, so y equals to x cube multiplied to minus 4 upon x plus c. Now further simplification, we get here y equals to x cube minus into 4 upon x plus c x cube. So y equals to minus 4 x square plus c x cube. Writing properly, so y equals to c x cube minus 4x square is required general solution. Example 5. Find the general solution of dy by dx plus y tan x equals to sec x. So step 1, given equation is dy by dx plus tan x into y equals to sec x. Comparing it with dy by dx plus py equals to q implies p equals to tan x and q equals to sec x. Now next step, that is step 2, to find integrating factor, that is e raised to integration of p dx, that is e raised to, what is the p? P is a tan x, integration of tan x nothing but log sec x, so sec x, that is a integrating factor. After that, solution, general solution is y into integrating factor equals to integration of q integrating factor with respect to x plus c. Y into integrating factor, that is sec x, and q is nothing but sec x, and integrating factor is sec x with respect to x plus c. So y sec x equals to integration of sec square x with respect to x plus c. So y sec x, and integration of sec square x is nothing but tan x plus c. This is required general solution. Example 6. Find the general solution of y into dx by dy equals to x plus 2y raised to 4. Now solution, we have the y dx by dy equals to x plus 2y raised to 4. Dividing both sides by y. After that, we get here dx by dy equals to x upon y plus 2y raised to 4 upon y. So that is dx by dy minus x upon y equals to 2y cube. Writing more better way, that is plus minus 1 upon y x equals to 2y cube. Comparing it with call it equation 1 and comparing with dx by dy plus px equals to q. So p is nothing but minus 1 upon y and q equals to 2y cube as per as the second rule. What is the second rule here? The second rule is nothing but dx by dy plus px equals to q. Then p and q are the constant. R over r, p and q can be the function of y, and integrating factor is given by e raised to integration of p dy, and the solution is x into integrating factor equals to q into integrating factor dy plus c. So this formula we are going to use there. So now we'll find out the integrating factor. So integrating factor equals to e raised to p dy, that is e raised to integration of minus 1 upon y dy, that is e raised to minus log y, that is equals to e raised to log y raised to minus 1 equals to y raised to minus 1 equals to 1 upon y. Therefore, integrating factor equals to 1 upon y. Now, after that, solution. What is the solution formula? The solution of the general equation is given by x into integrating factor equals to q into integrating factor dy. So this formula we are going to use. X into integrating factor, that is x integrating factor is 1 upon y equals to integration of q. What is the q? Q nothing but 2y cube, and the integrating factor is 1 upon y dy plus c. So x upon y equals to 2 taken outside, integration of y square with it to y, with respect to y, c. So x upon y equals to 2 y cube upon 3 plus c. Keeping c as it is. Later on we can write down c1, c2, etc. So that is also one more another way of selecting the constant. So that is a 3c upon 3. Now simplifying this. So we get here 3x equals to 2y raised to 4 plus 3cy. Let 3c is another constant equals to c1. This way also some teachers select. So 3x equals to 2y raised to 4 plus c1y. This is required general solution. So after going through these examples, I hope you can solve the problems from your textbook related to linear differential equations. If you feel some difficulties while solving these questions, then refer the question to me on my email address provided in the description box. Meet you again with another topic. Till then, wish you good luck. Before saying goodbye to you, I would like to request you like, share and subscribe the channel so that you will be getting updated videos every time and you will be able to watch and enjoy the mathematics video. Wish you good luck. All the best. Bye bye.